Hello, good evening everyone. Last time we discussed about the design of square column. So in today's lecture we'll discuss about the design of circular columns. So what is the meaning of a spiral column? Here the columns with helical reinforcement take more load than that of tied columns due to addition strength of the spirals. So what we'll see what is the difference between the tied column and the helical column. You'll see here, in case of tied columns here, we are using a tie around these longitudinal bars. So this is my tie. Okay. If you see the uh, longitudinal section, you will see that these are my vertical bars or main reinforcement, and these are lateral ties, which we call it as transverse steel also. And here, in case of a spiral column, we have these longitudinal bars here, and we have continuous spiral here. Okay, which is going around these longitudinal bars. So if you provide this type of arrangement, okay, so this column, that is a column with helical reinforcement, such type of column take more load than that of this type of column, that is your tied column, due to addition strength of the spiral. Because the strength of the spiral is more than that of the tied ties, so that's why the strength of the spiral column will be more than that of the tied columns. Okay. So what the code recommends? So clause 39.4 recommends a multiplying factor of 1.05 regarding the strength of such columns, means spiral columns. So this means that spiral columns take 5% more load as compared to the tied columns. So this 5% more means 1.05%. So this is a multiplying factor of 1.05 regarding the strength of spiral columns. The code further recommends that the ratio of the volume of helical reinforcement to the volume of core shall not be less than, what is this meaning here? Volume of helical reinforcement. What is the volume of this helical reinforcement in one loop? Okay, divided by volume of core. What is the core? Core means outer from this ring to the outer from this ring. So that is called your core. Okay, you can take the distance from outer of a spiral here to the outer of the spiral here, that is called your core. So this ratio, that is the ratio of volume of helical reinforcement to the volume of core, shall not be less than this value as per the clause 39.4.1. Okay, we will discuss what are the meaning of this. AG means gross area of concrete, AC means area of concrete only, FCK is the characteristic in the concrete, FI is the characteristic of steel. Okay. Now the governing equation of the spiral column may be written as, that this PU is equal to, when we discuss about the tied column, we don't have this 1.05 factor here. We have PU only 0.4 FCKAC plus 0.67 FYAS. Now here in this equation, what we are adding here, we have multiplied this 1.05 because the load taken by spiral column is 5% more than that of the tied column. So this is my equation for the spiral column. Now, what is the pitch of helical reinforcement? Now see that if suppose that this is my circular column here, and we have this inner circle here, which is nothing but your spiral reinforcement in the green line here. Okay. So what is the volume of helical reinforcement in one loop? When you consider this one circle, one green circle here, what is the volume of this helical reinforcement? So you know that the when you convert the circular length to a straight line, that is equal to pi times diameter. Okay. So this is my straight line. When I multiply this straight line with the area of the spiral, that becomes a volume. Okay. So how to calculate this straight length of this spiral in one loop? So that is equal to DC means diameter of the spiral. That is from outer of this green line to the outer of this green line. Okay. Now we have to take the length from center of this one to the center of this one. So I have to subtract the half diameter from here and half diameter from here. That is your full diameter, one full diameter. So that is equal to pi times DC minus phi of spiral. That is full diameter of the spiral reinforcement. that will give you the center line length of this spiral from here to here. Okay, so this length is known. When you multiply this length with the area of the spiral reinforcement, you got the volume of helical reinforcement in one. Okay, now come to the volume of core in one loop. How much is the volume of core in one loop? That is equal to area of core. Pi by 4 d square is the area of core from here to here. This is your area multiplied by pitch. Pitch is the pitch is this one here in this diagram. When you do that, this is your continuous spiral reinforcement here. Okay, so the distance from here to here, that is called your pitch. Okay, so you have already calculated the area. How much is the volume of core in one loop? This is equal to, this is my area of the core multiplied by this pitch, that is from here to here. So that is nothing but your volume of core. Now what is this here? DC is the diameter of the core. Okay, that is from outer here to the outer here. Okay, then phi SP means diameter of the spiral reinforcement. Then ASP means area of cross section of spiral reinforcement. Then P is the pitch of the spiral reinforcement. Now, to satisfy the condition of clause 39.4.1 of IS 456, the ratio of volume of helical reinforcement, okay, this divided by this, okay, volume of helical reinforcement to the volume of core shall not be less than this value. So this is the code requirement for circular columns. Okay, so in other words, you can say that this is my volume of helical reinforcement from here to here. Okay, and this is the volume of core. Okay, so this ratio, this divided by this is ratio. Okay, shall not be less than. This means that it should be more than which value? This value as per the code. So 0.36 AG over AC minus 1 FCK over F. Okay, so when you solve this expression, you will finally gives a pitch P. Pitch should be less than or equal to 11.1 DC minus 5 ASP. ASP Fy over D minus DC square into FCK. So what is this pitch? Pitch is nothing but this distance from here to here. Okay, so from this expression we can get the expression this one, which is nothing but the pitch of helical reinforcement, where D is the diameter of the column. Okay, diameter of circular column. Now let us take an example here. Design a circular column of 400 millimeter diameter with helical reinforcement subjected to an axial load of 1500 kilonewton under service dead end load. So this load which is given to you under service conditions. So you have to multiply by 1.5 to get it factored load. The column has an unsupported length of 3 meter. Unsupported length is 3 meter. And the column is effectively held in position at both the ends, but not against rotation. So this means that this is the case of both the ends are hinged. Okay, column effectively held in position at both the ends, but not against rotation. So this means the column can rotate, but the position is fixed. So this is the case of both the ends are hinged. You have to use M25 concrete and Fe415 steel. So you have to design the column. The diameter of the column is given to you, the load is given to you, the length of the column is given to you, and concrete and F415 grade is given to you. So what is the meaning of the design here? So design means you have to find out the area of steel, that how much is the area of longitudinal bar and how much is the area of spiral reinforcement. Okay, and what is the spacing. So let us start design here. This is step number 1, to check if the column is short or long. Okay, we have to first check it. If the L by R ratio is less than 12, it is a short column. If it is more than 12, then it is a long column. So what is L is given as 3000 millimeter, that is 3 meter. Diameter is also given 400 millimeter. So what is L effective? L effective because it is a column with both the ends are hinged. So effective length is equal to unsupported length. So it is equal to same 3000 millimeter. So what we have, LE over D. Okay, we have to calculate the slenderness ratio. 3000 divided by 400, it is comes out to 7.5, which is less than 12. So this means that it is a short column. Okay. Now calculate the gross area of column. Diameter is given pi by 4 d square. So this is my gross area of the column. Step number 2 is you have to check the minimum eccentricity. So what is the formula? E minimum is greater of either this value or 20 millimeter. Okay. So what is this? L is given as 3000 divided by 500. B means diameter is given to you as 400 divided by 30. So this comes out to be 19.33 or 20 millimeter. So greater between the two is 20 millimeter. So minimum eccentricity is 20 millimeter. Now second criteria is 0. You have to calculate 0.05 times of D. Okay. So this is 0.05. D is 420 is 20 millimeter. So in as per clause this 39.3 of IS 456, E minimum should not exceed 0.05 D. So this is my E minimum. It should not be more than this value. Now here both the eccentricities are the same. Okay, it should not be more than this value. So this means that we can use the equation in that clause of IS 456. Okay, for the design of short columns. Okay. So step number 3 is we have to calculate the area of steel. So we have, this is my equation for finding out for the design of the column. Pu is equal to 1.05 because of this circular column with the spiral reinforcement. 0.4 FCKAC plus 0.67 FYAS. So what is this? I don't know AC value here. So AC is equal to AG minus ASC. This is the gross area of concrete minus area of compression steel. Okay. This we have already calculated before. Okay. So this is my gross area minus ASC. I did not know what is ASC value. ASC means how much is the area of the compression steel. Okay. How much is the area of longitudinal bars. Okay. So just put the values here. This is my load, which is the service load is given you in the column. So I multiply with 1.5 to make it factored here. Okay. This is equal to 1.05 is it here. 0.4 FCK is 25. AC, in place of AC, I write this one. 125,663.7 minus ASC plus 0.67 as it is. FY is 415. ASC is unknown. So in this expression, only unknown is ASC. So we can solve this expression for ASC value. So which finally gives ASC is equal to 3304.29 millimeter square. Okay. If you calculate the percentage of the ASC, because diameter is 400 millimeters given to you, so this comes out to be 2.64% of gross area. Now minimum requirement for longitudinal steel 0.8%, you already know. Maximum requirement is 4%, so it is in between minimum and maximum. So this means that it is okay. Okay. So you have to provide some bars here. So I choose 11 20 mm diameter bars. Okay. And if you multiply this area of one bar with the 11 number of bars, that will comes out to total area is 3455 millimeter square. This area should be more than this area. Okay. So here it is more as longitudinal reinforcement. So this means that rho comes out, when you provide this much of area, the rho comes out to be 2.75%. Now this rho is between 0.8%, that is your minimum, and 4%, that is your maximum. Okay, hence it is okay. Next is you have to calculate the diameter of helical reinforcement. So one part is over, that is I have to provide 11 20 mm diameter longitudinal bars. Okay, the percentage of steel comes out to be 2.75%. What is the other requirement of the design? Other requirement is we have to find out what is the diameter of helical reinforcement and what is the pitch of helical reinforcement. Okay. So as per this clause, this diameter shall not be less than greater of number 1, 1/4 of the diameter of the largest longitudinal bar. What is the diameter of largest longitudinal bar here? It is 20 mm. So 1/4 means 20 by 4, that is 5 mm. So in any case, the diameter of the spiral reinforcement should be more than 5 mm. Second criteria, it should be more than or equal to 6 mm. Okay. So what is greater of? Greater is 6 here. So therefore, the diameter of the helical reinforcement is equal to 6 mm. Here. Now come to the last step, that is pitch of helical reinforcement. What is the pitch? This is the formula of the pitch we have already discussed. 11.1 DC minus phi ASP. DC is the diameter of core. Phi SP means diameter of spiral reinforcement. ASP means area of spiral reinforcement. Fy, you know. D, diameter of the column. DC, diameter of the core into FCK. Okay. Now, diameter of the column is given in the problem is 400 mm. Okay. So first, I have to calculate DC. What is the diameter of the core? So diameter of the core means outer from this green ring to the outer of this green ring here. Okay. So what is left here? This is cover here and this is cover here. So in columns we are using 41 cover here. So this 400 minus 40 on this side and 40 on this side. So we get 320 millimeter as a diameter of core. Second is phi of ASP, diameter of spiral reinforcement. We have already calculated in the previous step. It is 6 millimeter. ASP is how much? Pi by 4 into 6 square, that is 28 mm square. Now, this is my formula. 11.1, DC is 320, phi is 6, ASP is 28, Fy 415 divided by D square is 400 square minus DC is 320 square, FCK is 20. Okay. So when you solve this, the pitch comes out to be less than or equal to 28.125 mm. So whatever the pitch you have provided in this column, that should be either equal to 28 or less than 20. So you will check whether it is okay or not. So as per this clause, the maximum pitch is the lesser of. It should be the lesser of number 1, 75 millimeter. And number 2, core diameter divided by 6. Core diameter is 320 divided by 6. So this is 53 millimeter. So this means that the pitch, maximum pitch should be lesser of this value or this value. So what is the less value here? 53. So the pitch you provide in the column should be less than this value 53. Okay. So what our comes here? It is 28. So it is okay. Okay. Next is the minimum pitch is greater of. So this is my maximum pitch. And what is the minimum pitch? Is the greater of number 1 25 millimeter and number 2 3 times the diameter of the helical reinforcement. Diameter of helical reinforcement we have already taken as 6 millimeter. So this is 6, 3 into 6, 18. So minimum pitch is greater of between this and this value. So this is 25. Okay. So pitch should be more than or equal to 25 and less than 50. Okay. So whatever our comes here in the design is 28. So I have to use as adopt a pitch of 25 millimeter. So provide 6 mm diameter bars at the rate of 25 millimeter pitch forming the helix. Okay. So checking the clause of this 39.4.1 of IS 450C, this is the last step. Okay. To satisfy this condition, we have that is the volume of spiral reinforcement to the volume of core should be greater or equal to this value. Okay. Now we have to calculate the volume of helical reinforcement in one loop is equal to, we have already discussed pi times DC minus pi ASP into ASP. Everything is known to me. Okay. Volume of helical reinforcement in one loop means if you complete one circle of this loop, how much is the volume here? Okay. So for this volume, you have to multiply this length, okay, multiplied by the area. So this is my length from here, pi times DC minus phi. So this is length multiplied by the area. Okay. So this pi is known, DC is 320 minus phi is 6, ASP is 28. So this is the volume of helical reinforcement in one loop. Second is volume of core in one loop. Okay. Volume of core means area into pitch, area of the core into pitch. Now I know anything, pi by 4, DC is 320, pitch we have already calculated in the previous step as 25. So this is my volume of core in one loop. Okay. Their ratio, that is the volume of helical reinforcement to the volume of core. So this ratio, this divided by this value. So this ratio comes out to be 0.013. Now, what is the other requirement? Other requirement is this one. So I have to calculate this value. So when you put all these values here, you will come out you will have the value of 0.012. So naturally we'll see that this ratio is more than this ratio. Okay, so this means that this condition is also satisfied. Okay, so when all the conditions satisfied, this the design is complete. Okay, so this is all about your design of circular column. Thank you very much.